Okay, so in the previous lecture, we talked about inductive reasoning. We said inductive reasoning has to do with observing patterns. Okay, so the key thing here is for inductive reasoning, okay, inductive reasoning, we observed patterns, okay? So if you have anything that says in observing a pattern or whatever like that, that immediately clues you into inductive reasoning, okay? And we also kind of previewed saying that the other type would be deductive reasoning. And we'll talk about that today, okay? So that's inductive reasoning. We also talked about conditional statements and the inverse, the converse. So if P, then Q, and if this is the conditional statement, we had the inverse, converse, and contrapositive. Where the converse was if Q, then P. The converse is if not P, not Q. Contrapositive is not Q, if not Q, then not P. Okay, all right. Again, you will be asked to work on these on the test without a doubt, okay? So make sure you understand, given the statement, if P, then Q, what the inverse is. Oh, I see Evan's here with us now. So we would know what the inverse is, the converse is, and the contrapositive is, okay? So those were the two main things that we talked about in 2.1 and 2.2. So today we're going to do 2.3. We're going to talk about deductive reasoning. And we're also going to talk about a couple of things to utilize in applying deductive reasoning. Okay, so deductive reasoning. So 2.3, using deductive reasoning to verify conjectures. Okay, so deductive reasoning is you're not observing a pattern, you're actually applying logic. So you are applying logic, okay? When in doubt, think about Sherlock Holmes. Sherlock Holmes is by far the most famous persona that uses deductive reasoning, okay? All right. So let's go ahead and jump into example number 1 and see what we can find. Example number 1, urban legends and modern myths spread quickly through the media. Many websites and television shows are dedicated to confirming or disproving such myths. Like what? What kind of shows are there that do these things?
Mythbusters.
Mythbusters, exactly. Is each conclusion a result of inductive or deductive reasoning? So they're going to give us A and B, and we have to figure out whether they're using inductive reasoning or deductive reasoning, okay? A, there is a myth that toilets and sinks drain in opposite directions in the southern and northern hemispheres. However, if you were to observe sinks draining in the two hemispheres, you would see that this myth is false. Okay, so are we applying logic here or are we observing a pattern? What are we doing? What does it say? It says if you were to observe sinks draining, right? So obviously this would be an inductive reasoning, right? B, there is a myth that you should not touch a baby bird that has fallen from its nest because the mother bird will disown the baby if she detects human scent. However, biologists have shown that birds cannot detect human scent. Therefore, the myth cannot be true. Okay, so are we observing a pattern here? No, we're not, right? We're applying a certain logic that says that since the birds cannot detect human scent, there is no way a mother bird would disown a baby bird because of the human scent. Okay, so this would be a case of deductive reasoning, right? So that would be deductive reasoning, okay? All right, so the first example or first thing that we're going to do using deductive reasoning is called the law of detachment. Law of detachment. Okay. Law of detachment. Very top of page 89, it says, if this is true, P then Q is true. If the conditional statement is true and P is true, then Q is true. Law of detachment. Okay. So if the conditional statement P, if P then Q is true, and P is true, the hypothesis part is true, then Q is true. Okay? So that's the law of detachment. So what does this all mean? Let's go ahead and run example number 2. We'll do example number 2. Example number 2A, given if two segments are congruent, then they have the same length. Okay? The conjecture, so what they're saying that if the segment A and segment AB and XY are congruent, okay, then the conjecture would be AB, the length AB is the same as the length XY. So first of all, it kind of makes sense, right? If they're congruent, they have to have the same length, right? Okay, so that doesn't mean it's true through the law of detachment, right? So let's verify each step and see if we can see if this is true through the law of detachment. Okay, so first of all, we're going to identify the hypothesis and conclusion here, right? So what is the hypothesis? The hypothesis is if they are congruent, right? And then we have the conclusion is they have the same length. Okay, so given the statement that this, okay, matches this, it is true, and we know that the P, this guy is true, therefore this guy has to be true. So that would be the 3-step process of using, law of detachment. So you have to be able to, again, identify what is the hypothesis and then what is the conclusion. Okay, all right. So the conjecture is valid. This is the conjecture, and we proved that this guy is valid because this is the conclusion part of if P then Q. And we also know that if P is true, then this guy is true. Okay, so that was A. Let's see if we can do B. B, if you are tardy 3 times, you must go to detention. Okay, so the hypothesis here is what? What is the hypothesis? Kayla, what is the hypothesis here?
The hypothesis would be if P is Q, that part, like the second part of it.
No, it's the first part, right? The first part is the hypothesis, right? So the hypothesis would be if you are tardy 3 times. That would be the hypothesis here, okay? Right, what is the conclusion here? Jose?
The conclusion would be you must go to detention.
Correct. You must go to detention is the conclusion, right?
Yeah.
Okay. So the conjecture is that Shay was tardy. Oh, no, okay. Then Shay, okay, if you are tardy, you must go to detention. Shay is in detention. So the conjecture is that Shay is tardy at least 3 times. Okay? So the conclusion, Shay is in detention, does match the conclusion of the true conditional, correct? Okay? But that doesn't mean that the hypothesis is true. It doesn't mean that he was tardy 3 times. In other words, he could have been in detention for other reasons, correct? Right? So the conjecture here is not necessarily true. Okay? So that is a law of detachment. That's a law of detachment. Next one we're going to do is the law of syllogism. The law of syllogism says that if P then Q and Q then R is true, if these are both true, then PR is true. Okay, so what does this remind you of? Have you guys seen anything like this in your prior math experience? Does this remind you of the transitive law? If you remember hearing the transitive law, right? It's kind of like that, right? In other words, if A is equal to B and B is equal to C, then A is equal to C. It's kind of the same thing, right? If P then Q is true, and if Q then R is true, then obviously if P then R has to be true. Okay, so that's the law of syllogism. Okay, so let's go and see if we can verify this or work a couple of examples here. Example number 3. Verifying the conjecture by using the law of syllogism. Determine if each conjecture is valid by the law of syllogism. Okay. A, given if angle A is less than 90, then angle A is acute. If A is acute, then it is not a right angle. Okay. The conjecture is if angle A is less than 90, then it is not a right angle. Okay. So do we have this here? If P, so P would be what? A is less than 90, right? P would be A is less than 90, right? Q would be what? Q would be, then A is acute. A is acute, okay? So over here, I would have to have A is acute, then what? Then it's not a right angle. R would be not a right angle. So for the law of syllogism to be applied correctly, P would be A is less than 90, and R would be not a right angle. So is that what they're asking? Is that what they're conjecturing here? If A is less than 90, the conjecture is that, then it is not a right angle. So this is work. This does work, right? This works with the law of syllogism, okay? Okay, let's see if we can do the next example. Example number B. Okay, example B says, given if a number is divisible by 4, then it is divisible by 2. So P would be divisible by 4, where Q is going to be divisible by 2, correct? Which means that this guy should read divisible by 2. Okay, so this is not correct, right? Because it has, if a number is even, then it is divisible by 2. In other words, it looks like they're going to have R then Q here, where Q is divisible by 2, and R being even. Okay? So, and the conjecture is what? Then the number is divisible by 4, so that would be P. This is correct. Divisible by 4. Then R would be this. R is supposed to be even. Okay, R is even, so this is even. So that is correct. So what is wrong here? The wrong is that they have R is Q, right? If R, then Q. So the second part should have read what? If divisible by 2, then it's even, right? Except that is switched, which means that we cannot, even though what they're saying is correct, it is not correct by using the law of syllogism. Does that make sense? You get it? In other words, just because the statements work doesn't mean that you're applying the law of syllogism or the law, for that matter, the law of detachment correctly. Okay, so you have to be able to verify step by step that they're applying the laws correctly. Okay. So example number 4, applying the laws of deductive reasoning. Draw a conclusion from the given information. If a team wins 10 games, then they play in the finals. If a team plays in the finals, then they travel to Boston. Ravens won 10 games, therefore, Ravens will travel to Boston, right? And what is this? What kind of law are we applying here? This is the law of syllogism, right? The law of syllogism. Okay. Next one. If two angles form a linear pair, then they are adjacent. If two angles are adjacent, then they share a side 1. Then they share a side. 1 and 2 form a linear pair, therefore they share a side. Okay? So in other words, this is kind of different, totally different from the law, from the inductive reasoning that we had earlier, right? We are actually applying logic here, okay? So, what did we learn today? We talked about what deductive reasoning is, and then we talked about the law of detachment and the law of syllogism, okay? So those are the 3 things that you need to get out of this lecture is what is deductive reasoning, what is the law of detachment, and what is the law of syllogism. And you have to be able to apply those or read a statement or a conjecture and see if these laws, the 1 or the 2, have been applied properly. Okay? Are there any questions? Any questions I can answer before we go start the homework? All right, let's go ahead and work on the homework then.